Hi, so today we will be learning about comparing fractions. The concept of comparing fractions requires you to be able to find equivalent fractions. So if you're not familiar with equivalent fractions or you're not comfortable with it yet, it'll be a good idea to look at the equivalent fractions video first before returning to this video. So to compare fractions, there are three main methods depending on the type of fractions that are given to us. So the first method is comparing with respect to half. In order for us to do this, we will either need one, to be able to list all the equivalent fractions of half. Okay, until 6/12 it will be enough. Or at the start, it will be very useful for us to have a chart like this that tells us the equivalent fractions of half with different denominators on a number line. Okay, so let's try using these two things to help us today. So for example, okay, so let's look at the first question. We want to compare 2 7s and 3 5ths. So what we can do with this is we can use our number line to help us. So for example, okay, if I'm looking at my number lines with even denominators, we can tell that all these fractions on the vertical dotted line, they are all equivalent fractions. So half, 2 quarters, 3 6, 4 8s, 5 10s, 6 12s, they are all equivalent fractions of half, which is why they are on the same vertical dotted line. Any fraction that is on the left will be smaller than half, and any fraction that is on the right will be greater than half. This is because just like any number line, fractions on the left are always smaller than fractions on the right. It gets a bit tricky when the denominators are odd because, as you can see, there are no equivalent fractions with odd denominators. So there are no equivalent fractions of half with odd denominators. Okay, but it doesn't matter. If we look at this dotted vertical line, it's still the same. Any fraction that is on the left of this dotted line is less than half. Any fraction that is on the right of this dotted line is more than half. Okay, so let's look at our question again. We want 2 7s and 3 5ths. So 2 7s and 3 5ths, they both have odd denominators. If you see here, 2 7s is on the left of the dotted line, which means that it is smaller than half. 3 5ths is on the right of the dotted line, which means that it is more than half. Okay, so immediately, because I know 2 7s is less than half and 3 5ths is more than half, I immediately know that 2 7s is less than 3 5ths. Do you see how we did this? Now, it might be a bit more complicated when we have more than two numbers. Okay, so let's look at this second example. 2 5ths, 5 9s, and half. Okay, so let's check 2 5ths and 5 9s first. So as you can see, they both still have odd denominators. 2 5ths is on the left side of the vertical line, which means that it is less than half. 5 9s is on the right side of the vertical line, which means that it is more than half. And so, because 2 5ths is less than half, 5 9s is more than half, we know that 2 5ths is smaller than half, and 5 9s is greater than half. So we can order it pretty quickly. Okay, what about if we have 1 quarter, 5/7 and 3/6. This is where writing out the equivalent fractions gets helpful, especially when we are in a test or an exam and we don't have the number lines to help us. Okay, as we can tell, 3/6 is actually an equivalent fraction of half. So it doesn't matter, we can compare the other two fractions first, 1/4 and 5/7. 5/7, as we can tell, is on the right side of the vertical dotted line, which means that 5/7 is greater than half. 1/4 has an even denominator and it is on the left side of the vertical dotted line. So it is less than half. So immediately I know that 1/4 is less than half. 5/7 is more than half. And 3/6 is equivalent to half. So I can just write my greatest fraction will be 5/7 because it is more than half. And followed by 3/6, which is equivalent to half. And then 1/4, which is the smallest fraction here. So as you can see, if I know how to compare with respect to half, I can do this pretty quickly. Let's look at the second method now. The second method is used when I'm comparing related fractions. So what do related fractions mean? Related fractions mean that when I look at my denominators, okay, one of them will be divisible by the other. So in this case, I can take 10 divided by 5, which will give me a whole number. What should I do for comparing related fractions? I will first take the fraction with a smaller denominator. So in this case, when I'm comparing 5 and 10, 5 is the smaller denominator. Okay. So I'll take the fraction with the smaller denominator, and I will need to find an equivalent fraction that has the same denominator as the one with the larger denominator. So this means that I'm changing it such that my denominator is also 10, which means I need to multiply 5 by 2. And to find equivalent fractions, I'll need to multiply my numerator by the same number, which will give me 8. Now I can compare 7/10 and 8/10. Because, as we learned previously, when the denominator is the same, we just need to look at the numerator. And immediately we can tell that 7/10 is less than 8/10. And I can conclude that 7/10 is less than 4/5. So remember, when we are given fractions, our answer needs to be in terms of the given fractions. Okay, now we have half, 5/6, and 9/12. There are actually two methods to do this question. So we can use the method that we looked at previously, which is comparing with respect to half. We have 5/6, 9/12. Okay. So I can either look at this. 5/6 is on the left, it's on the right side of the vertical dotted line. 9/12 as well. So they are both greater than half. Since they are both greater than half, we immediately know that half is the smallest fraction. Or if I cannot tell that half is the smallest fraction, it is fine. I can still compare related fractions since I can take 12 divided by 2 and 12 divided by 6. Okay, so I need to change all my fractions such that they have denominator 12. This would mean that I take 6 times 2 and 5 times 2. Okay, since I already concluded that half is the smallest fraction, I just need to compare 9/12 and 10/12. And I know that 9/12 is smaller than 10/12. So I know that 9/12 comes next before 5/6. So remember, I always write the original fraction that was given. So what if I don't realize that half is the smallest yet? I can also use the same method. I can find the equivalent fraction. Okay, but this is not necessary if you can immediately tell that half is the smallest fraction. So I can also convert it to equivalent fraction, which gives me 6/12. Then I will compare 9/12, 10/12, and 6/12, which will give me the same answer. Last but not least, the third method will be comparing unrelated fractions. What does unrelated fractions mean? It means that the denominators won't be divisible by each other. So in this case, I know that I cannot take 8 divided by 5 to give me a whole number. So these are unrelated fractions. The second case, I cannot take 7 divided by 4 to give me a whole number. These are unrelated fractions. Okay, the method to solving unrelated fractions are a bit more difficult because they require more steps, but it has the same idea as the previous method. Firstly, I need to list the multiplication tables of my denominators. So I will take 5, 10, 15, 20, 25, 30, 35, 40. Okay, I don't have any space left, so I'm just going to stop here. And for 8, and I'm going to stop here. Now, what I need to do is I need to find the number that appears in both the multiplication tables of 5 and 8. So if you look, it is 40. So now I need to convert both fractions into equivalent fractions with denominator 40. Okay. So in order to get 40, I will need to multiply 5 by 8. And to get equivalent fractions, my numerator has also to be multiplied by 8. So this gives me 16 in my numerator. Okay, now the other fraction, 3/8. I need to convert it into an equivalent fraction with denominator 40 as well. This means I take 8 times 5. My numerator, I will also need to times 5, which gives me 15. Immediately, I can tell that because my denominator is the same, I only need to compare my numerator, and I know that 16 is greater than 15. And so I can conclude that 2/5 is greater than 3/8. Okay, our final answer, we always write the fractions that were given to us in the question. And our next example, 6/7, 3/4. I do the same thing. I list all the multiplication tables of the denominator first. 7, 14, 21, 28, 35, 42. Okay, I have enough for now. Okay, and same as just now, I will need to find the number that appears in both the multiplication tables of 7 and 4. So in this case, it will be 28. Okay, so now I'll need to convert both fractions such that they are of denominator 28. So 6/7. If I want to convert it to denominator 28, I know I need to take 7 times 4. So my numerator, I also need to multiply by 4. I get 24. 3/4. To get denominator 28, I need to multiply by 7, which means my numerator, I need to multiply by 7, I get 21. Okay, so I have this. Because my denominator is the same, I only compare my numerator, and 24 is greater than 21. And my final conclusion is 6/7 is greater than 3/4.